This is our final project titled State Line Weir Image Processing. Our team is conducted of Laura Stavila, Braden Remington, Amanda Variel, and our course instructor is Dr. Ruby. This is our final project for machine vision and image processing. Our problem statement, we've divided into 3 sections. So the accurate measurement analysis of water flow over a weir is essential for effective management of our water resources, the flood control, and hydropower generation of said weir. Traditional methods of measuring water flow over these weirs are often labor-intensive, time-consuming, and prone to error. Image processing is a new technique that is being implemented to potentially automate these measurements and analyze the water flow of the weirs, improving the accuracy and efficiency of these tasks. The objective of this study was to develop and evaluate some images which were provided to us to provide an algorithm for accurate measurements and analysis of the weir. As for image acquisition system, again, these images were acquired from a fixed ground-based camera. These images provided quantitative information that could improve stream flow monitoring. The images that were provided to us were over the course of 52 weeks, one image given to us each week over the year of 2014. Out of these 52 images, we selected 3, one at the beginning of the year, one in the middle of the year, and one towards the end of the year. As for our block diagram, as you can see here, we first input our images into MATLAB. Our pre-processing method includes our removing our noise with a high pass as well as a Fourier transform. We are also providing histogram equalization and verifying our SNR values from the previous project of signal processing. Our processing and analysis, we are using segmentation. Segmentation involves dividing up an image into different regions and going through and comparing its different values. This could be color, texture, etc. And lastly, we're classifying these images and just comparing them to one another. The methods used for this project was to convert to grayscale. Again, use histogram equalization. We're showing you the before we equalize the histogram and after we equalize the images. Then we are applying fast Fourier transform, high pass, applying our high pass to our Fourier, and then converting it to spatial domain. We plot and measure our points of the weir and plot these points. Once we plot them, we compare them, and we compute our SNR values of our images.
So these are our original images. We selected 3 with similar background colorations just for easier comparisons. And then these are our grayscale images and our histograms. And then in this slide, we binarized each cropped grayscale image and then calculated the percent coverage values based off of the white, which is the discharge. The more chop on the water means the more discharge coming over the flow, which and then means there's a higher stage of water. And here is measuring the distance of the weir. As you can see, the red point starts at the same place on each image, and the green dot starts at the end of the weir to get the accurate measurement.
And as for here, you can see those distances measured in pixels being plotted versus the dates they were taken. This is to show the change in weir distance across the dates. And this is the corresponding signal to noise ratio. This tells us the ratio of signal of the area we focused on. And the image 1 here you can see has a low quality with 18.34 as an SNR value, opposed to image 3 with the 42.14 SNR value. As for our impact assessment, global impact, the weirs can have global impact altering the natural flow of water and affecting the carbon cycle. When built weirs can change the amount of time of the water that flows downstream, has effects on rivers and coastal ecosystems. As for the economic impact, collecting information on weirs can be beneficial towards irrigation water for crops and generating hydroelectric power. As well as for the environmental impact, weirs can have environmental impacts by altering the habitat and migration patterns of aquatic species, affecting water quality, contributing the loss of biodiversity. Continuing on this impact assessment, the health impacts for this, weirs can have health impacts on communities by affecting the quality of the drinking water, this impact being caused by stagnant water. As for the ethical impact, weirs can have ethical impacts by affecting the livelihoods and cultural practices of local communities. In conclusion, after processing these images, the team was able to correlate the distance of Weir with the time of the year. And to further straighten this correlation, the team's method of image processing and analyzing must be applied to all images collected in the year of 2014, being all 52 images 1 week for each of the year. And now on for the live video run of the MATLAB code.